During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Learning outcomes. By the end of this lesson, you should be able to state the function of a parapet wall, state the maximum height and minimum thickness of a parapet wall, draw a sectional sketch of a parapet wall showing all measurements, flashings and D.P.Cs. State what efflorescence is. List 2 methods of preventing sulfate attack on mortar. Parapet walls occur around the edges of roofs, which may be pitched or flat. The purpose of the parapet wall is to provide a balustrade at roof level and also to prevent the penetration of dampness into the walling below. Building regulations. 1. Parapet walls should be provided with a D.P.C at least 150 mm above the line of intersection between the roof and the wall. 2. They can be cavity or solid wall construction, but must be at least 200 mm in thickness. 3. The height should not exceed 4 times the thickness. 4. They should be provided with a weather-resistant coping, which should project beyond the face of the wall. 5. Good weather-resistant mortar and hard, burnt or dense bricks should be used for building parapet walls. Copings. They should have a weathering or slope on the upper surface to shed any rain quickly. They should keep the water away from the face of the wall as much as possible. The material for the coping should be capable of resisting the action of the weather. They should give a good appearance at the top of the wall. Movement joints should be every 3 meters. A concrete feather edge capping. Bedded on fresh mortar. The D.P.C should have a rigid support underneath it, for example slate. Saddleback coping. We can see the throating underneath the saddleback coping. This is to create a drip to keep the water away from the face of the wall or to prevent the water, excessive amounts of water, running down the face of the wall. Again, take note that the D.P.C is bedded in fresh mortar, with fresh mortar underneath and above the D.P.C in order not to break the bond between the wall and the capping. Types of parapet walls. We have a high parapet for flat roofs with access for people. We could have a low parapet for flat or pitched roofs. We could also have a solid parapet wall or a cavity parapet wall. D.P.C. Build D.P.C trays into the inner leaf not less than 150 mm above the finished roof. Step cavity tray down to the outer leaf by not less than 150 mm also. To achieve good adhesion, D.P.C should be bedded on fresh mortar and sandwiched in between the mortar. D.P.C should project 5 mm or be flush with the face of the wall. All coping should have supported D.P.C underneath them. This is to prevent the D.P.C from sagging and subsequently holding water or moisture, and then what would happen is over a period of time that D.P.C would rot away. Running laps should be at least 100 mm and sealed with either a liquid adhesive or an adhesive tape. Weep holes should be spaced at a minimum of 1 metre centres. Fibrous filter plugs are positioned in weep holes to prevent staining of brickwork below. Metal flashings add abutments to roof and parapet walls. Flashings are used to weather the junction between D.P.Cs and roof finishes. Flashings must be in the same joint as the D.P.C and underneath the D.P.C, as seen in the picture opposite. They can be fixed after the wall has been built by either leaving a rebate or raking out the joint to allow the flashing to sit in onto the brickwork 25 mm. Then we can wedge it and seal it with silicone, as seen in the picture opposite. They can also be built in by the bricklayer. This is slightly different. Lead which is single welted is used and built 50 mm in from the brickwork face, as seen in the diagram opposite. The single welt prevents water travelling along the top of the flashing and passing in through the wall. Mortar and bricks. All joints should be solid and weathered, for example key jointed. Movement joints should be more regular as the wall is exposed to extreme weather, so expansion joints should be at least every 6 metres. Sulfate resisting cement may be recommended, and bricks with a low soluble salt content also. Additives such as styrene butadiene may be added to increase water resistance. Efflorescence. Clay bricks contain salts, for example sodium sulfate or magnesium sulfate. Rain dissolves these salts and form a solution inside the brick. When the water evaporates through the face of the brick, it leaves the salt crystals behind. These are unsightly on the face of the wall, and any concentration of salts which collect behind the surface of the brick may cause spalling of the face due to the expansion of the salts, and this is called cryptoefflorescence. When the efflorescence or salt build up behind the face of the brickwork, it blows the face off the brick. This is why hard burnt or dense bricks with a low salt content are used for building parapet walls. Sulfate attack on mortars. This results from a chemical reaction between sulfate in solution, which is just salt in solution, and a constituent of Portland cement, tricalcium aluminate or C3A. When mixed together, they form calcium sulfoaluminate hydrate, which occupies a greater space, resulting in expansion. This can cause mortar to crumble and expand. Sulfate attack will only take place under certain conditions. Removal of any one of these following conditions would prevent sulfate attack from occurring. 1. To protect bricks from saturation. 2. Use bricks with a low soluble salt content. Or 3. Use sulfate resisting cement. Conclusion. Parapet walls provide a balustrade at roof level and also prevent the penetration of dampness into walling below. A parapet wall should be at least 200 mm thick and the height should not exceed 4 times the thickness. Flashings and D.P.Cs should be provided at least 150 mm up from the intersection of the wall and the roof. Efflorescents are salt crystals that appear on the face of brickwork due to saturation and evaporation. To prevent sulfate attack on mortar, either protect the bricks from saturation, use bricks with a low soluble salt content, or use sulfate resisting cement.